Okay, good morning, lads and ladies. Welcome back to MAC1105 College Algebra. It's a pleasure to be with you here this morning. I'd like to remind you, I would really appreciate it if you are in a situation where you can, that you turn on your cameras and kind of be here with me so I can follow how you're interpreting the material, and just being able to see your face, see your reaction as this stuff comes in is very, very helpful to me. So if you are somewhere you can, I understand if you're not. If you are somewhere you can, thank you, Elena. I appreciate if you could turn on your camera just so we can kind of be here with each other as a class as much as is possible. Today we're going to talk about absolute value. Absolute value is something that you're probably familiar with on several levels, but maybe not with the degree of formality that we're going to approach it today. We're going to learn how to graph functions that involve the absolute value operator, and we're going to learn how to solve equations and inequalities involving the absolute value operator. So that's the vibe. You did have a homework and a quiz due today, of course, as always, right? At the start of class, there is always a set of things due. And today was homework 4 and quiz 4, which is on applications of linear functions. I had a few people come to my office hours over the last few days for help with that. That was nice getting to talk with you guys and see how it was going. I'd just like to remind you that if you're struggling with any of this material, or if any of it just feels at all uncomfortable, that coming to office hours is a great way to get through that, to get past that, to get to a place where you can be 100% confident on the test. So that's how I want you to feel. Coming into that test, I want you to be 100% confident, zero stress. And it is possible. This is MAC1105, section number 015, which is college algebra. And the date today is the 20th of January, 2022. Today we're going to be talking about absolute value. So we're going to cover the definition, functions, graphs, domain and range, etc. Right? All of the things that we wanted to do with functions in general last week, we're doing with the absolute value functions today. Increasing, decreasing, all of that stuff. We're also going to talk about equations. So you can structure equations with absolute values. We're going to see how to solve those. Some of it's a little counterintuitive. And the same is true of the inequalities. So I'm just curious, how many of us are bound for calculus? If you give me a react of any flavor in Zoom, thumbs up or any sort of reaction in Zoom, if your intention is to proceed through the math classes into a calculus class eventually. Okay, a handful, but not all of us. Oh, there we go. Yeah, some more folks. So there's a fun saying in mathematics that algebra is all about the equal sign and calculus is all about the inequality. It might not seem like that when you first encounter those things. A lot of people get very excited that calculus returns exact answers for a lot of things that we would think are very hard to get exact answers for. But the way that the theorems are proved, the way that the results are actually achieved is through very, very careful use of inequalities. So I'm excited to share with you guys some inequality stuff today. Let me just show you really quickly the homework we're going to be kind of approaching. And yeah, in response to that DM, of course, certainly happy to extend things. The way that works in my open math, you just send me a Canvas message saying, you know, I need this assignment extended. And I will assign you late passes in MOM for those assignments. So if you could please just send me a little Canvas message letting me know that that's what you need. I'll set that up for you. So here's the homework set. And this is going to be due on Thursday along with the today's Thursday, right? This is going to be due next Tuesday along with the associated quiz. I'm also opening the homework and quiz for the first quadratic functions set in case you want to work ahead, because I know probably most of you have encountered those before. You see here, there's a lot of graphing at the start. When you want to use one of these graphing utilities, they're pretty intuitive. You just click this little guy, Oh, it might not work because I'm in the preview setting. Just click this little guy, and then you can, oh, there it is, and you can select some points that are on the graph to draw the graph. Okay. Now here it knows I'm trying to graph an absolute value function, so it's always going to draw a graph with roughly that shape, but hopefully you kind of see how this works. Your first click is going to be that sort of base point there, the place where the graph sort of turns around, and then your second click will determine the graph. So yeah, that's it. Let's get to it. The proper way to define absolute value requires some notation that you might not be familiar with. And that's the notation for piecewise functions. So first, I'm going to try to describe this to you in words, and then I'll show you the standard symbols. The absolute value of a real number x is defined to be x if x is positive and negative x if x is negative. And this might seem a little bit counterintuitive, so let's take a second, right? When you think about the absolute value, usually you think of it as just making the number positive, right? But you should ask, how do you do that? So if you want to take the absolute value of a number x, right? Pretend this is just some number. Then if that number is already positive, you're just going to leave it alone, right? The absolute value of 2 is 2. The absolute value of pi is pi. The absolute value of 12 is 12. But if that number is negative, if x happens to be negative, how do you take a negative number and make it positive? Well, you slap on another negative, right? Negative negative 2 is 2. Negative negative pi is pi. Notation, right? The absolute value of x is denoted So intuitively, absolute value does what you think it does. Takes whatever you feed it and makes it positive, which means if it's already positive, it leaves it alone. If it was negative, it makes it positive. And you can think of doing that in a bunch of different ways. But the standard way of actually saying you're going to take a negative number and make it positive is multiply by -1 again. And the notation here, not that you really need this, because in this class we don't study piecewise functions, but in pre-calculus, all of a sudden you do have piecewise functions and nobody ever really introduces them. In piecewise notation, this is the absolute value of x equals x if x is positive. And we include 0 here, if x is greater than or equal to 0. So if you have a number that is 0 or larger, its absolute value is just that number, and negative x if x is less than 0. So the notation here, this is called a piecewise function. You're not required to remember this specific collection of symbols, but you do need to remember this first sentence here, which is the verbal version of this piecewise expression. Okay, so for example, the absolute value of 3 is just 3. The absolute value of 0 is 0. The absolute value of -17 is positive 17. absolute value of negative pi over 2 is positive pi over 2, right? It does what you think it does. Could I get a react in Zoom? And I'm asking for a bit of participation today. Could I get a react in Zoom? If this piecewise notation, this kind of big curly brace, and then functions, and then qualifiers, if this is the first time you've seen this piecewise notation. So again, any sort of react is fine, thumbs up or smiley face, whatever you want. If it's the first time you've seen that curly brace notation. Okay, cool. Yeah, I think the first time I saw it was college algebra also. Okay, so we can define all sorts of functions in terms of this absolute value operator. The natural one to look at first is just f of x equals the absolute value of x. So what I'd like to do now is sketch the graph of the function f of x equals absolute value of x by making a table of values. What's that mean? It means we're going to pick a bunch of x values to plug in. And we're going to see what the outputs are associated with those. And, I usually like to arrange these vertically. You can arrange them horizontally. Either way, it's fine. I'm just going to pick integers like -3, -2, -1, 0, 1, 2, and 3. We can put whatever numbers we want in here, but these are nice, easy numbers to work with, so I might as well. So if I plug -3 into this function, what do I get out? What is the absolute value of -3? Yeah, 3. If I plug -2 into this function, what I get out is 2, because the absolute value of -2 is 2. If I plug -1 in, we get 1 out. If I plug 0 in, I get 0 out. If I plug 1 in, I get 1 out, 2, and 3. Right? I don't think we need to keep writing this time. So when you make a table like this, each row tells you a point on the graph. Right? From this first row, I deduce that the point -3, 3 is on the graph from this first row. The point -2, 2 is on the graph from the second row. The point -1, 1 is on the graph. The point 0, 0 is on the graph. The point 1, 1 is on the graph. The point 2, 2, and 3, 3. These are all on the graph. And that's how these tables allow us to graph functions. So let's draw the graph. Type here 1, 2, 3. 1. The first point we know for sure is on the graph is -3, 3. That's right here. Right, you go over to -3 on the x-axis and up to +3 on the y-axis. This is my y-axis. This is my x-axis. -2, 2 is right here. -1, 1 is right here. 0, 0 is right here. 1, 1 is right here. 2, 2 is right here. And 3, comma 3 is up here. And you might ask, okay, this looks like it's a straight line here, and this looks like it's a straight line here. So let's just go ahead and sketch those in now. Modulo my bad art. Nice big fat points. Modulo my bad drawing skills. These are straight lines. So this is what the graph of the absolute value function looks like. It's this V shape. It's kind of pointy. It's got a hard corner down here. It's not like a soft curve. It's a hard corner. No matter how tight you zoom in on this, it will always look like a hard corner. And one of the things that I think would be good to do, just really quick, is to take a look at one of these in a graphing calculator. While I wait for Wabbit to boot up, I'd like to find the domain, range, intervals of increase and decrease, and any means or maxes for the function of the. Yeah, and just a quick reminder, remember everything that I do on the document camera here, this needs to go into your notes. So make sure you're getting this down. If you need time to write, if I'm moving too quickly, let me know. Let's start with the domain and range. You guys remember how to get domains and ranges from the graph, right? We play that smooshing game. So let me turn this. If I come in here and I smoosh this graph down onto the x-axis, this whole line over here is going to get smooshed down onto the negative axis, hitting everything over here. This portion of the graph on the right is going to get smooshed down and hit everything over here. So what is my domain? Those arrows indicate that the graph continues going like that forever and ever, continues going like that forever and ever. What interval of x values do I get when I smoosh that whole graph down onto the x-axis? Yeah, very good. Thank you, guys. That's negative infinity to infinity. Otherwise known as all real numbers. All right, in other words, you can plug any number you want into the absolute value function. There's no number you can plug in here that gets you in trouble. What about the range? If I smoosh this graph onto the y-axis, I come in like this and go, well, then this whole piece is going to get smooshed up onto the positive y-axis. This piece is going to get smooshed up onto the positive y-axis also. So what interval of y values do I get for my range?
0 to infinity.
0 to infinity is correct. Ah, there it is. Yeah, Destiny got it in the chat. So I got a bunch of answers that are mostly correct, but we need to be a little bit careful. It is true that the range, the set of all the y values that gets hit, is the set of from 0 to infinity, the interval from 0 to infinity. We always use a parentheses on the infinity, right? So I had a lot of people tell me 0 to infinity, and so far everything here is correct. But the point here at the origin, the y value on that point is 0. And that is a point on the graph, right? This point right here, 0, 0, is a point on the graph. Specifically, that y value 0 is a y value that's on the graph. So we need to make sure to include that, the bracket. All right. Are there any questions about why we're using a bracket here instead of a parentheses? If that number gets hit, if that number is a part of the range, then we need to include it with the bracket. And since there is a point whose y value is 0, 0 is in the range. So this is my domain, and this is my range. Where is this function increasing? And remember how we described this. This is the part where we need to be a little bit careful.
It's open intervals 0 to infinity.
Perfect. When we ask where is this function increasing, we're asking for what x values. So for what x values, if we're walking along the graph, are we going uphill? Well, it's definitely this part of the graph that is increasing. And the x values there are just from 0 to infinity. And that's an open interval. We always use open intervals of x values for increasing and decreasing. So with that in mind, where is this function decreasing? Oh, really quick. So 0 to 3, it is true that we're increasing on the open interval 0 to 3, but we continue increasing, right? So it would be an open interval, and we have to make sure we continue it all the way out. Yeah, Alejandro and Chadi both got the decreasing. So we're decreasing on this part of the graph here, right? This is the part of the graph that is going downhill. And the interval of x values there is this interval of x values, right? All the way from negative infinity up to 0. And again, it's always open intervals for increasing and decreasing. Right here at x equals 0, we're neither increasing nor decreasing. We're going downhill, 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 and then ka-chunk, uphill, 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 uphill. It's a very sudden and abrupt transition. So right there at that point, we're not doing either. Okay, are there any minima or maxima? Any mins or maxes?
Can you clarify what that is again?
So remember, a min, a quick reminder about mins and maxes. A local min is a point that is lower than any other points nearby. So if you kind of just look at a little window around that point, if that's the lowest point anywhere in that window, then that's a local min. A local max is the same thing, but it should be the tallest point nearby. So if you can put a little window around that point, where that point is the tallest point in that window, that's a local max. This is a local min. If a point is the tallest point anywhere on the graph, then that's called an absolute max. And this one is also a local max. So if you look at just a little window, this is the tallest point in that window. Also, if you look everywhere on the graph, this is the tallest point anywhere on the graph. So an absolute max is the tallest point anywhere on the graph. A local max is, like we said, it's a point where if you put a little window around it, it's the tallest point in that window. So coming back to our purple function here, are there any points on this graph that are taller than all the other points? Remember, these arrows indicate it goes like that forever.
Is it 3?
Well, let's see. So if I put a little window around this point, is that the tallest point in that window? I don't think so, because if you look just to the right, like right here, this point is taller than this point. Right, like there's a point over here at 4,4, there's a point over here at 5,5. Those y values are all bigger than 3. So 3 couldn't be an absolute max, and it's also not a local max, because if I put a little window around it, even here, like if you look just here at like 3.5 comma 3.5, that's taller also. But there is one point on this graph that has one of those properties, like 2 of those properties actually. Yeah, Destiny's got it. There's a min at 0. If I put a little window around this point at 0, notice that that point, this point right here, the point 0, 0, which is on the graph, is the lowest point in this window. It's also the lowest point anywhere on the graph, right? The graph never dips below that point. So we would say there is a local and absolute min at x equals 0. And remember the way we do this, the location, like where is the min, that's the x value. And the min value, that's the y value. That would be f of 0, which is 0. And that is both local and absolute. Okay. So this is our kind of starting point for this lesson, right? Is the graph of this absolute value function. We're going to look at many kind of modified versions of this graph. And to help you with that, I want to show you how to do this in the calculator. I know that you all have, Desmos and shit like that on your phones, but when it comes to the exam, you're going to have to rely on your TI-83, TI-84. So let's see if we can get this to graph in the TI-83, TI-84. Now remember, if I want to draw the graph of a function in my calculator, I need to hit this y equals button up here. That's where I'm going to type my thing in. And then what I want to do is type the absolute value of x here. But I don't see a button for absolute value anywhere. Does anybody know where to find the absolute value on the calculator? If I remember correctly, I think we have to, there's an abs thing in here. There it is. All right, let me show you here. So if you want to type an absolute value in your graphing calculator, the way you do it, let's come out of here. You hit math, scroll over to num, and then your first option there is abs, ABS. That stands for absolute value. Hit enter. And now you see you've got some absolute value bars that you can type in. So if I just hit an X here, that's it. I have typed y1 equals the absolute value of x. So the graph it's going to draw is y equals the absolute value of x. That's my graph. There we go. Okay. And we can do that out here in the regular setup also, right? Outside of the graphing. If you hit math, scroll over to num, select abs, hit enter. Then you can type negative 3.1415926, blah, blah, blah. And it'll return the absolute value of that number. So in your graphing calculator, if you want to work with the absolute value, hit math, scroll over to num, and then abs and hit enter. We wanted to graph the function. So we hit y equals, typed absolute value, and then x. Again, the way we did that is by hitting math, scroll over to num, absolute value, enter, and then this button right here, x, t, theta, and that button right there is how you type your variable. So just type x and then hit graph. You may want to play with your Windows settings, right? Like to get our graph, we were only looking from -3 to 3. And our y values here, we had our y, we didn't show any of the negative y-axis, so I could just say like -1 or something. 3. And this is more scaled like ours. Okay. So what I'd like to do next is just look at some slightly different absolute value functions, see if we can draw the graphs, find domains and stuff. And we can use the graphing calculator to help us. We don't always need to make a table, but we do need to be able to sketch the graphs. So let's sketch the graph of f of x equals the absolute value of x minus 3. And we'll state domain, range, increasing, decreasing, axis, all that stuff. All right, this time though, instead of making a table, I'll just use my calculator. So I'm going to hit clear everything out. I'm going to hit y equals. That's going to bring me back here. Now, I don't want to look at this graph anymore, so I'm going to clear him out. But I do want to graph this function, right? Absolute value of x minus 3. So again, I'll hit math, scroll over to num, select the first item there, which is absolute value. And then inside my absolute value, I'm going to type x minus 3. And then we're going to hit graph. Wow. What do we think is going on here? Does that graph have the same sort of shape as the one we were just looking at? What's wrong with that picture? Yeah, very good. It's an issue with the window settings, right? I'm not seeing much of the graph. I'm not able to see the cool stuff. I can't see like where it turns around. I can't see that hard edge. It looks like maybe I'm looking at half of it or even less. So what we should do is just kind of zoom out by readjusting our window settings. Let's go back to that standard window. That's always a good place to start. And see how that looks. Oh, okay. And then if I want to, remember, I can use my trace function to kind of walk around on the graph and see where things are. So it looks like my y-intercept here is somewhere around 3. Yeah, here it is, 0, 3. So when x is 0, that's your y-intercept. When x is 0, y is 3. And then this pointy bit over here, if I keep scrolling over, looks like maybe it's also around 3. Yeah, 2.9, y is 0, 0.021, and then 3.19, we're going back up. So what I'm going to do is I'm going to readjust my window settings to kind of center this guy. So I'm going to change my x min to something like -5, change my x max to something like, and we'll leave that as 10 maybe, that's okay. X scale 1, y min, no part of that graph was below the y-axis. So again, we can keep that at like -1 or something. And y max, let's make that like 8. And kind of bring us over here, where we're looking at the parts of the graph that we care about, right? This is a much nicer picture for us. And if we wanted to look at a table rather than making one by hand, we can do that. Who remembers how to pull up a table on the TI-83 or TI-84? Instead of drawing one by hand over here. So if we go to stat and then go to edit, that's where we enter a table, right? If we need to enter a table of values to do like regression with, that's where we do that. But if I want to have the calculator generate a table from a function I've entered, that's a little different.
Is it
Second and graph.
Yeah, that's it. That's it. So I'll hit second and then graph, because you see the blue lettering right here says table. So the blue button and then the graph button will make us a table. And here we go. And you can go up to go backwards in the X values. You can go down to go forwards in the Y values. So I can get all sorts of points that are on this graph from this table. Let's start just with the picture though. I'm just going to reproduce the shape at the moment. And we'll worry about the details in a second. There it is. It's not bad. And then I'd like to know a few things. I'd like to know, what's this point? What's this point? Maybe a couple other points on there. So that's where I can use my table. I could also use my trace function, but remember the trace function tends to spit out these weird numbers. So if I want to get nicer values, I can hit second and graph to pull up my table. So when X is 0, Y is 3. This Y-intercept right here is 3. So this is the point 0, 3. And then let's scroll down a little bit. 1, 2, 3. When X is equal to 3, Y is equal to 0. Right? So when Y is 0, that's your X-intercept. So this point right here, the X-intercept, which is also like our little turnaround point, that's the point 3, 0. And then the rule, I'll let you guys know right now, the rule I have on tests, and I think a good rule of thumb is you should always put at least 3 points labeled explicitly and clearly on your graph, at least 3. So maybe another good point, let's just see when X is 4, what do we have? Okay, 4, 1. So right here, just to the right of 3, this would be 4, 1. And there's a pretty nice looking graph. Now someone mentioned that their table looks a little different than mine. You can change the settings for the table, just like you can change the settings for the window, right? To make your different parts of your graph visible. If you want to change the settings for your table just like that, you see above the window button in blue, it says TBL-SET, that's table settings. So if you hit second and window, you can tell this thing where to start the table, right? Like what that first X value at the top should be. And then delta table here, this is how big a step the X values take. So right now it's set at table start -2, delta table 1. I change table start to -10, just so we can see what this does. I'll hit enter. And then I'll hit second graph to come back to my table. See, now the first X value there is -10. And I can still scroll up and down. If I want to change the sort of X values I see in the table, like maybe instead of taking steps of 1, I'd like to take steps of 1/2 or 0.5. And do that, and then I'll hit second graph to bring up my table again. And now you see we've got lots of points on here with some decimals. The X's, instead of going up by 1 each time, now go up by 1/2 or 0.5. So the points we get are like 0, 3, 0.5, 2.5. So if I looked right here, right, just between 0 and 1, the point on the graph right here is 0.5, 2.5. And we can adjust those table settings however you want. You can have it take all sorts of weird step sizes and start at any big or strange number you want. But for our purposes, this is a good graph. Remember to label your axes. That's it. Beautiful. So you want the domain, the range, increasing, decreasing, mins, and maxes. What is my domain? Smooshing everything down onto the x-axis.
It's open intervals, -infinity to infinity.
Yeah,
Also, I have a question.
sure.
So when I my absolute value isn't going in with the lines, it's going in with parentheses and then erroring when I ask it to graph it.
Can I ask what kind of calculator are you using?
TI-84.
Okay, and when you type your absolute value, are you using the same sort of thing I am? You're hitting math and then going over to abs like this?
Yeah, so I would go to window, I mean, not window, to the YE equals,
Mhm.
and then doing the same thing.
So type math.
Math, num, abs, enter.
And then, so we got to put something in here. That's the thing.
Mhm.
So inside the absolute value, we have to put something like x or
X.
x minus 3.
I
And
did
then-
that. Let's see.
And you're still getting weird stuff?
Yep.
Let's see. It is possible to reset the thing. You might have some weird setting in there. I'm not too sure. Maybe that would be a good one to Canvas message me on. If you
Okay.
could take a picture of it and send it to me, I might be able to figure that out for you.
All right, thanks.
Yeah, sorry about that. So
It's
let's
okay.
continue with our problem here. What is the range of this function? If I smoosh everything here onto the y-axis, what gets hit? So yeah, remember we're going to take the whole thing and push it onto the y-axis. So this point would get smooshed over to here. This point would get smooshed over to here. All of these would get smooshed here. So the range is going to be the same as last time. It's going to be 0 to infinity. Now it's a bracket on the 0 because the 0 does get hit. Right? So all the points down here, they have y values smaller than 3. So all of these guys, all these y values, they do get hit by all of this part of the graph. So we do include 0 to 3. And then the pieces up here, they would get smooshed onto the stuff bigger than 3. Where is this function increasing?
Three to infinity.
Good. So the interval of x values where this function is increasing is the interval from 3 to infinity. This is the part of the graph that is increasing. And remember, we always just want to give the x values there. So that's these x values. What sort of delimiters should I use? We always put a parentheses on infinity, of course. What about the 3? Yeah, very good. Open parentheses, right? Always open intervals of x values. Where is this function decreasing?
Negative infinity to 3.
Excellent, right? This is the part of the graph that is decreasing, and we're just wanting the x values there. So that's this interval of x values, which is negative infinity up to 3 and open everywhere, of course. Okay, there is again just one min or max. Where is the min? Good, right? So this point is both a local and absolute minimum. And we would say the local and absolute min is at x equals 3. And the min value is what? Very good. The min value is 0, which is f of 3. And that's exactly how I would write it. You could just say the min value is 0 if you want, right? Okay, let's try something a little bit more complicated. And this will be the last sort of sketch the graph problem, I promise. I'm just going to say state all the stuff, right? Domain, range, increasing, decreasing, mins, maxes. So this function, still an absolute value function, right? The variable is still inside the absolute value symbols. Only now we've got a bunch of other stuff going on. There's an x plus 1 inside the absolute value, and I'm subtracting 2 times that from 4. If I wanted to, I could make a table of values, right? I could start plugging in x's, simplifying, or I can just use my calculator to draw a nice graph. I'll come in here and clear this out and type 4 minus 2. And now I need to type my absolute value. So I'll hit math, num, abs, enter. That's 4 minus 2 times the absolute value of x plus 1. Everybody see how I was able to enter that? Graph. And again, I can see most of the good stuff, but I'm kind of like zoomed in over here. I want to focus my graph over here. Looks like this is at -1, 4. So let's try to make that closer to the center. Let's go from maybe -8 to +3, something like that. For my x's and for my y's. That's okay. Y max is +8, y min -1. I'm all right with that. That looks like it'll do about what I want. Maybe we want to bring that x min in a little bit. How about -5? Okay, this is good, right? This shows me again everything I really want. The y max is bigger than it needs to be. We can bring that down a little bit to about 6. There we go. Lovely picture. I would be happy to write down the calculator steps. Yeah, the calculator steps for graphing these or for adjusting the window or? Sure, sure. Let me go ahead and let's get through this, like state the things and draw the graph, and then I'll summarize by writing down the steps. So here, I'll keep my graph up on the calculator. We can use our trace function again to get a feel for where things are. So it looks like this peak up here is at -1, 4. Looks like the x-intercepts, there's 2 of them now. This one looks like it's at like -3. And this one looks like it's around +1. We can check with a table. So I'll go second trace to get, sorry, that's calc. That's not what I wanted. Yeah. All right. Sorry, second graph to bring up my table. And I can look for some of those points. So we had the -1, 4. That was like my little peak. Let's get in here and do this. Okay, so -1, 1, 2, 3, 4. That's where my like a little peak or turnaround was. Always nice to label that explicitly. Other interesting stuff, the y-intercept was 0, 2. So that's right here. The x-intercept on the right, that's 1, 0. That's right here. So that first part of my graph looked like this. And then going back up to go down in the x values, what did we have? -3, 0 is over here. That's this other x-intercept. So I've got my graph now with at least 3 points labeled. And we're in good shape. We can go ahead and describe all that stuff. Again, labeling the axes is good. There it is, 10 out of 10, perfect graph, A+. What's my domain here? There's a running theme with these domains. Let's smoosh this whole graph onto the x-axis. All this stuff will get smooshed into here. This guy will get smooshed onto all of this. And this portion will get smooshed onto all of this. So the domain again is all real numbers. Negative infinity to infinity. The range we're going to have to think about a little bit. If I smoosh the whole graph down onto the y-axis, this, what y values get hit?
Negative infinity to 4.
Very good, right? This point would get smooshed onto 4. All of this part of the graph would get smooshed onto this part of the y-axis. This part of the graph and this part of the graph will get smooshed onto this part of the y-axis. And then all this stuff is going to get smooshed. It just goes down and down forever, right? So your range is everything up to and including 4. So that's from negative infinity up to and including 4. Okay. Where is this function increasing?
Negative infinity to -1.
Excellent. This is the part of the graph that is increasing, and the x values there are these x values. Negative infinity up to -1. And decreasing, where are we decreasing? This is the part of the graph, right? Almost, careful. Remember, we're just looking for the x values. So -1, we do start increasing, decreasing. So right here at -1 is where we start decreasing. And then those x values are from -1, yeah, good, all the way out to infinity. So remember, we're just looking for the x values. Excellent. Okay. Are there any mins or maxes here? Any mins? Let's start with that. Yeah, good. No mins. No mins here. What about maxes? Are there any points on this graph that are taller than the other points? Good. there is a local and absolute max at -1. And the max value is what? So this thing spits out its largest possible number when x is -1. And the actual output there, the number it gets spit out, the largest y value on the graph is what?
Is it f -1 equals 4?
Yeah, we could just say 4, or you could say it's f of -1, which is equal to 4. Very good. Very good. And again, if you just said 4, that's fine, right? But when we write this, we're saying it's the output that comes from -1, and that output is 4. Okay, so yeah, recapping the steps to graph these things in the calculator. First, you're going to hit the y equals button, which is in the top left. Then you'll type your function using the math button, scrolling over to num, and then down to abs, and hit enter. That's how you'll actually get your absolute value symbols in there. So if you need to type any sort of weird absolute value expression, this is all. I want to type any sort of weird absolute value expression like 2 times the absolute value of x plus 7, and then like -6, right? We can type it like that. Then you will hit graph. Which is in the top right. And then your last step here is maybe to play with the window settings. Until you see any intercepts or all intercepts, mins and maxes. All right, and that window settings you might need to play with for a minute to get a nice picture.
I have a quick question.
Sure.
I fixed my calculator. I had to reset it.
Okay.
But yeah, thankfully. How when you're looking at the table, how do you, I feel like I missed this. Like when there's like a bunch of different numbers, how do you know like where it stops? Like where the local min or max is, or do you have to find that off the graph?
Yeah, that really has to come from the graph. So if we look at the graph, oh, that's right, I put something weird in here. So let me, if I want to go back to the standard one, mins and maxes generally much easier to find from the graph. Sometimes you can find them from the table, but usually what you'll want to do is look at the graph to get an idea. We can use the trace function here, right? So if I hit the trace button, then I can scroll left or right to move this guy around on the graph. And that'll give me an idea, right? I see, oh, okay, it looks like somewhere around -7 is where this is happening. And then if I want to see exactly what that point is, I could go to the second graph to bring up my table, scroll till I get to -7, and then I see, oh, okay, that point is -7, -6.
All right, cool, thanks.
Yeah, no problem. Okay. So besides graphing these functions and playing those games that we were playing, we also want to be able to solve equations and inequalities that involve absolute values. And these are a little bit tricky. So let me start with an example. Math teachers never tell you to do this. So I want you to play along with me for a minute here. We're going to do the thing you're never supposed to do. Just do it in your head, right? What sort of numbers could you plug into this equation to make it true? What sort of numbers for x, when you take their absolute value, will give you 3? Yeah, very good. Right? We can say, well, the absolute value of 3 is equal to 3. So x equals 3 works. Also, the absolute value of -3 is 3. So x equals -3 works. Those are your two solutions, -3 and +3. This basic logic is what you need to solve any and all absolute value equations. But when they get more complicated, you need to be more careful. So we're not going to be able to do all of these in our head, but the kind of in your head reasoning is what will work. This hints at what I call an unpacking rule. For absolute values, for absolute value equations. Here's the rule. If you have the absolute value of some stuff, right? You've got your variable is in here, maybe some numbers are in here, maybe there's some addition, subtraction, whatever. If you have the absolute value of some stuff is equal to a constant C, where C is any positive constant, then either that stuff is equal to C, or that stuff with a negative on it is equal to C. Which you could think of, the second one I would encourage you to think of as putting the negative on the other side. So in a single line, the way we would write this is the absolute value of f of x is equal to C means either f of x is equal to C or f of x is equal to -C. And this is the rule. So to solve an absolute value equation, what you want to do is get the absolute value part alone, and it could have any combination of variables and constants inside. Get the absolute value thing alone. And then the way you get rid of the absolute value is by setting up two different equations. One where the inside is equal to whatever this constant is, and the other one where the inside is equal to the negative version of that constant. And it's precisely because of this. Right? If the absolute value of some stuff is equal to 3, then that stuff is either 3 or -3. Make sense? Let's try it. Now let's see. Let me just put a 1 over. Okay, I love you, sweetie. Yeah. All right. So we want to get the absolute value part alone, and then we'll use the unpacking rule. So what we're going to do is start by subtracting this 2 over. If I subtract 2 from both sides, what's left is negative absolute value of 3x plus 4 equals 1 minus 2, that's negative 1. And I just subtracted the 2. Now, I'm going to divide both sides by negative 1 to get rid of this negative. So that gives me the absolute value of 3x plus 4 equals negative 1 divided by negative 1 is positive 1. Now I'm ready to use my unpacking rule. So what we did here, we subtracted 2. We divided both sides by negative 1. And now we're going to use the unpacking rule. The unpacking rule says the absolute value of some stuff is equal to 1 if that stuff is equal to 1, or that stuff is equal to negative 1. And then I'll solve each of those. Each one of these will give me a solution. Those 2 solutions are the solutions to the original equation. So here I can subtract 4 from both sides. And I'll get 3x equals 1 minus 4 is negative 3. Then divide both sides by 3. Negative 3 divided by 3 is negative 1. So one of my solutions here is negative 1. Over here, if I subtract 4 from both sides, I'll get 3x equals negative 1 minus 4 is negative 5. And then if I divide both sides by 3, I get x equals negative 5/3. So that fraction is your answer. Okay. There are also unpacking rules for inequalities. I'm going to write these. Yeah, so both of these numbers are solutions or answers for this equation. If you plug negative 1 into this equation, you'll get a true statement. If you plug negative 5/3 into this equation, you will get a true statement. The unpacking rules for inequalities, if you have the absolute value of some stuff is less than a positive constant c, this means you have to think about this a little bit carefully to understand where it comes from. A number can have an absolute value smaller than, say, 5, if that number is smaller than 5, and also bigger than -5. So this means negative C is less than the stuff inside the absolute value is less than the positive version. I'll do an example in a second. I do want to point something out here, and that's that if you change this to a less than or equal to, then these also change to less than or equal to. And there's a version of this for greater than or equal to also. You have the absolute value of some stuff is greater than the constant C. This means either the stuff inside is bigger than the positive version of that constant, or the stuff inside is smaller than the negative version of that constant. And these can also be replaced by weak inequalities. So I'll try to take a look at one of each of these. I think we probably have time for like one of each before we have to go. All right, but these are your unpacking rules for absolute value inequalities, just like the unpacking rules for equations. The first inequality over here is what's called a compound inequality. And you can work with these the same way you work with equations or regular inequalities. You can add and subtract everywhere through the inequality. The second one, if you have an absolute value is greater than some constant, then you'll need to work each of the resulting inequalities separately. Let's look at an example. Here I have the absolute value of x minus 3 is less than 7. So this is an inequality that looks like this. All right, I've got the absolute value of some stuff with my variable in it is less than, right? Remember, less than is this one, greater than is this one. The way to remember that, by the way, think of it like a little alligator. We're in Gainesville, right? The alligator eats the bigger guy. So if this says absolute value of f of x, alligator eating C, means that C is the bigger guy. So I'm saying C is bigger than this, or this is smaller than C. So here, the absolute value is already isolated. There is no like 5 plus the absolute value or 3 minus the absolute value or anything like that. So our first step would be to unpack. It's already in this form. According to this unpacking rule, my inequality right here is equivalent to -7 is less than x minus 3 is less than +7. And the way you solve this compound inequality is by trying to get x alone in the middle. All right, I want to get x alone, just like with an equation. The only thing that's keeping x from being alone right now is this -3, right? We're subtracting 3 from x. So if I add 3 everywhere in this inequality, -7 plus 3 is -4. X minus 3 plus 3 is x. And 7 plus 3 is 10. So this says -4 is less than x is less than 10. And that should remind you of something. That's an interval. Remember the definition of an open interval. I'm saying my -4 is less than x. In other words, x is bigger than -4, so bigger than -4. But also, x is less than 10. So I've got to be bigger than -4 and also smaller than 10. That means I'm between -4 and 10. And since this is a strict inequality, -4 and 10 themselves are not allowed. i.e., the solution is the interval -4 to 10, like this. So the solution set to this inequality has infinitely many numbers, right? -3, -2.9, -1, 0, 1/2, pi, infinitely many numbers in here. Lots of whole numbers, but also lots of decimals and fractions, irrational numbers. So you have to write it as an interval. There's no way to list all of them. I know we're going over just by a second here. I want to point out something that can happen with these, and then look at one example of the other type. Here's an absolute value equation. Maxwell, sorry, my dog. If I want to solve this, I would have to get my absolute value alone and then apply my unpacking rule. But something funny is going to happen here. So to get my absolute value alone, I would divide both sides by 2. That will give me the absolute value of x is equal to -10 divided by 2 is -5. Now, according to my unpacking rule, if I have the absolute value of some stuff is equal to a constant, I set the stuff inside equal to that constant, or the negative version of that constant. But there was a little thing that I added about that first unpacking rule. You guys remember? Positive constant. Can the absolute value of any number ever be negative?
No.
No, this is impossible. Absolute values never spit out negative numbers. So there's no number x you can plug in here that will make this true. After you take the absolute value, it's going to become positive. So you'll never get -5. You need to be careful with that on the inequalities also. Right? So be mindful that some absolute value equations and inequalities have no solution, and you can think about it and figure out whether you're in that situation or not from the step where you've isolated the absolute value. All right, let's do one of the last inequality types. How about this? I've got the absolute value of 2x plus 1 minus 3 is greater than or equal to 2. I need to isolate the absolute value and then apply my unpacking rule. So to get the absolute value alone, to isolate the absolute value, first I'm going to add 3 to both sides. That will give me absolute value of 2x plus 1 is greater than or equal to 2 plus 3 is 5. Now this, this is in the form of the unpacking rule, right? It's the absolute value of some stuff is greater than or equal to some constant. To unpack this, we use the second unpacking rule for absolute values. Either this stuff is bigger than 5, or that stuff is more negative than -5. And we solve each of those on their own. 2x plus 1 is greater than or equal to 5. I subtract 1. That gives me 2x is greater than or equal to 4. Then I divide both sides by 2, and I get x is greater than or equal to 2. Now we'll come over here and solve this one, and then we'll sketch them and write the answer as an interval. Again, subtract 1. 2x is less than or equal to -5 minus 1 is -6. Divide both sides by 2. X is less than or equal to -6 divided by 2 is -3. So it says, my original inequality is logically equivalent to the statement that x is bigger than or equal to 2, or x is less than or equal to -3.
Wouldn't the sign switch because you're dividing by a negative?
If you divide by a negative, then the sense of the inequality flips over. But I never divided by a negative. The thing I divided by here in both of these, to go from here to here and from here to here, I divided by 2. The thing on the right was negative and it stayed negative. If this was a -2 that I divided by, then the inequality would flip over. That is true. So it's the thing that you're dividing by, the thing that you're putting downstairs, that's the thing. If that is negative, the inequality flips over. So let's sketch each of these sets. X is greater than or equal to 2. Well, that means x is 2 or bigger. X is less than or equal to -3. That means we are anywhere over here up to and including -3. So what is this set? This is -infinity to -3 bracket unioned with 2 to infinity. All right, and that is your final answer here. And that note, I do like what Tyson told us there. We should say this. If you divide through an inequality by a negative number, we call it the sense of the inequality flips. So for example, if I have something like -3x is greater than 21, and I divide both sides by -3, then that will become x is less than 21 divided by -3 is -7, like this. Okay, we have gone a good bit over time, so I'm going to stop here. Go ahead and start working on this next homework set on absolute values. It's pretty fun. I think most of it is stuff you've been exposed to in one way or another before. Maybe some of this inequality stuff is new. If anything gives you a hard time, I do have an office hour starting in 5 minutes. Happy to talk about it there. You can send me a Canvas message. If you do that, take a picture of your work. Let me see what you've tried, and that will really help me give you a better answer. But if you're struggling with any of this at all, please talk to me for help. Tutors are good, right? The Learning Commons tutors, happy to help you. But there's nothing quite like talking to the person who writes and grades your tests, is there? So happy to do that. Want to hear from you, want to hear how things are going. Please don't be shy. And that is it from me for today. I'll see you guys next time.